All right, for your next example here, we're going to have you simplify some other functions that require a little deeper of an understanding of log functions. So right now, I'm asking you to simplify two functions right now that actually have the log function as an exponent and the exponential function as part of your log. So in order to do this, you need to have a good understanding of inverse properties. So what I want to look at right here is the definition. Oh, sorry about that. I want you to have a good understanding of the inverse properties. So what we're looking at right here is this part in our book. So by definition of a logarithm, it follows that the logarithmic function f of x equals log base b of x is the inverse of the exponential function f of x equals b of x. Now, what this means, remember your definition of inverse functions. So because we're taking, so remember, because log base b of x, in order to switch that, we take our b and turn that into the base of our exponent and have that equal to whatever, so equal to x. That means that log base b of x equals g. We would just take x equal b base f of g equals x. That is the inverse function of b of x. So what that means is if we take our function g and plug in f of x, we would get log base b of b to the x equals x, and log, or b to the log base b of x equals x. Now, I don't want you to worry too much about the definition right here. The important things to understand are these two equations. So what we're doing is we're evaluating some functions. We're evaluating some functions right here that are in this format. So if we have, we have a log base b, if we have our input that has an exponent in it, and if these two bases are the same, then our exponent is just equal to the output. Also, if we have a function that has the log as an exponent, and the log of our exponent is the same as the base of our exponent, we know that the log value is equal to our solution. Now, again, I want you to just think about these definitions. So what that means is if we have a log and our base is equivalent to the base of our log value, so look at this, only happens in certain situations. We're saying that we have as our function, it's a log function, and our log value it's actually an exponential function, and the base of our log is equal to the base of our log value, then we know this is equivalent to just whatever our exponent is here. So again, this is only in certain situations, and think about what situations this require. So we have a log value, a log function, and as our log function, instead of just being a number here, like log base b of 64, our input here is actually a base with an exponent. We're saying that if that happens, and also it just so happens that the base of whatever our log is equal to the base of our log input, then we know that this is equal to whatever our exponent is here. That's one value. That's one rule using our inverse properties. The next rule is that if we have an exponential function and our exponent just so happens to be a log function or a log expression, and that log has the same base as the base of our exponent, then we know that this is equivalent to whatever the value of our log is. Okay? Now, these two expressions are going to take a little bit of getting used to. You're going to have to work with these a few times to really understand how to use them. Again, these only apply into certain situations. Again, in this first one, your expression is going to require, it's going to be a log expression, and it's going to require that the base of your log is equal to the base of your expression input. Then you know that this is equivalent to whatever your exponent is. The second one, it's going to require another special situation. It's going to be an exponential expression, and this happens when your exponent happens to be a log expression, and another requirement is that the base of your log has to be equal to the base of your exponent. Then we know this is equal to whatever your log value is. We know that this whole expression here is equal to the log value. Okay. So I would recommend writing these down, and then we're going to click on this and then look at a couple expressions to go ahead and calculate. But the key here is knowing these two rules. Okay, and these two rules are given to us using inverse properties. I'm not as concerned with you understanding the definition of the inverse properties and how we calculated these, but I do want you to know these two rules right here. So let's go ahead and let's go back and look at a couple examples. So we want to simplify 10 to the log 4 power. Okay. Now, remember, one thing to understand is when you have just a log written right here, and on your calculator you'll sometimes see the log situation, what that means is that we're actually having log base 10. Okay, that is our standard log value. It's just like when you see the square root of a number, like the square root of x, it's implied that your index is 2. Same thing, when you just see the log written right here, it's implied that your base is 10. Okay, just remember that right here. This is the same on your calculator. When you see your log button, that means that your base is 10 right here. Okay, this is, again, just like when you see the square root of a number without an index, it is implied that your square root is 2. So what you need to know right here is that this is actually log base 10. So when what we're seeing right here is that the 10 to the log base 10 of a number equals 4. Go back here, remember our values. We know right here when we're seeing a base with our exponent log base 10 equals x. So we're seeing 10 to the log base 10 of x. We know that this is just equal to x. Let's go back here. We're seeing 10 to the log base 10. So our rule right here is we know that when we have a base to the log base 10 of a number, we know that this is just equal to that number. That's our rule right here. The rule we're looking is right back on this page right here. So when we simplify this, we know that this is just equal to 4. And that's given to us by this power. Okay, sorry, I clicked twice. Just look at this first one right here. We know that our rule is when we have the base and the exponent is log base p, log base b of a number, that's x. We know that our value is equal to x. Okay, let's look at the second number right here. I'm clicking ahead a little bit right here. So we're trying to use another rule right here to give us this expression. So let's go back. Now we've got log base 5 of 25 to the x. So what we want to use right here is this one right here, log base b of a number of the same base to the x power. So the key right here is that the base of our log is equal to the base of our exponent. Now let's see if we have that here. Okay, so I'm going to click up here so we go back to this. Don't mind this. I just want to go back so that we don't see this first step. Now remember, our rule right here is that we need to have the log base b of b to the x. equals x. So right here, we need to turn this into something that has the same base as the base we see right here. So in order to use this expression or this rule, we need the base of this exponent to be equal to the base of our log. Now just because that's not true how it's written right here, we might be able to rewrite this into a way that we can use this rule. So let's go ahead and see if we can do that. Now, we know that we might be able to use this rule because 25 is just a power of 5. So let's see what we can do first. Now, we can rewrite 25 as just 5 squared. Okay? And when we do that, we can turn this into an expression where we have our base of our log and our base of our exponent as the same thing. Now, now that we have that, let's go ahead and simplify this so that we can go ahead and use our rule. So when we go ahead and use our power of a power property, we can rewrite this expression as log base 5 of 5 to the 2x power. Now we can use our rule right here. And we get our property is log base b of an exponent of b to the x power. We know that this just equals x. So if we take that rule and apply it here, we can turn this into just 2x as our result. Okay, again, we're using these two rules right here. We're using these two rules and just applying them to some situations. So we're evaluating or simplifying some expressions using those two rules. Now, what I want you guys to do right now is I want you to simplify these two expressions using those two rules. And then I'm going to want you to enter them into the box that I'm going to give you.